Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good day everyone. So today we are going to continue our second part of our chapter 2, which is the Fourier series and the applications. Okay, so as you can see, these are the learning outcomes of our subject of course, which is the signal and system. So technically for the chapter 2 part 2 in the Fourier series and application, we focus more on CNO number 2, which is use Fourier series analysis to describe signal and linear time invariant continuous time system in the time domain. Alright, so in chapter 1 and in chapter 2, in part 1, previously we have learned about the sinusoid signal, the representation of the signal in terms of the Fourier spectrum and the frequency spectrum, the time domain and the frequency domain, the double-sided, the single-sided, and so on. So now, how we can relate to the Fourier series and the effect of the Fourier series characteristic. So it is very important for you to refer to the appendices that I asked you to print previously, all right, so that you can refer. And for your information, the appendices also will be given in the final exam, so I hope that you are able to read. Okay, you are able to read the appendices, otherwise it's quite difficult for you to use the appendices in order to solve the given questions. Okay. Alright, so when we talk about the Fourier series, okay, it is usually referred or can be related to the periodic signal in finite cosine and also the sine. And then if you can see here, we know that when we talk about the periodic signal, meaning that the signal repeat itself at equal interval of the time, which is the t naught. Alright, so for example, the Vt is equal to Vt plus minus n t naught, where the t naught, the time, can be solved by using 1 over f naught. So we know that the frequency, the relationship between the frequency and also the angular frequency is 2 pi f, right? 2 pi f, the angular frequency. Okay, so I can write here. So omega is equal to 2 pi f. Okay, whereby you can substitute, okay, the f with the 2 pi t, 2 pi over t, right? 2 pi over t. Okay, so technically f is equal to 1 over t or vice versa lah. Okay, next. Alright, so now, okay, the Fourier series representation, okay, the Fourier series can be represented in the two forms. Okay, the first one is the trigonometric and the second one the complex exponential. Okay, so technically what you have learned in our part 1 is the continuous in the part 2. Okay, so please make sure that you are familiar how to convert the trigonometric, okay, in terms of the sign, in terms of the from sine to the positive cos, okay, from the negative cos to the positive cos, and then you have to know the basic how to convert the trigonometric form into the complex exponential form. So we know that from the trigonometric form you can draw the frequency spectrum, okay, in terms of the single-sided spectrum, the single-sided frequency spectrum, okay, which are in the amplitude spectrum and also the phase spectrum, okay, the magnitude and also the phase spectrum. Okay, meanwhile for the complex exponential, okay, we can relate the complex exponential with the with the double-sided. Okay, sometimes in the question of the Fourier series it will give you the signal, the periodic signal, so therefore you have to identify the type of the signal and how to apply the appendices for the particular signal. Okay, so sometimes given to you the spectrums, okay, the magnitude and also the phase spectrum, so you have to form the exponential signal, and then you have to convert to the trigo, and then from the trigo you have to plot the single-sided. Okay, so there are very multiple types of questions that can be asked, so it is very important for you to know how to convert, okay, those and what are the relationship of the trigonometric and also the complex exponential. Okay, and then how from the complex exponential to draw the double-sided, and from the trigonometric how to draw the single-sided is very important. Okay, all right. So when we talk about the Fourier series, okay, we know that it is the it can be in terms of in the form of the trigonometric Fourier series and also the complex exponential. Okay, the representation of the complicated periodic signal in the frequency domain by its frequency component spectrum, and the representation of the musical sound as sum of wave of various frequencies in audible example. These are the example of the Fourier series. Okay, so the trigonometric, okay, so when we refer to the trigonometric Fourier series, you can see in your appendices, this is the formula. Okay, the formula of the Fourier series general form of the trigonometric. You have the an over 2 plus, okay, the summation of from infinity to n, started with n is equal to 1, an cos n omega t omega naught t plus bn sine n omega naught t. This one you don't have to remember because it will be given in your appendices. All right, so what you have to do is, okay, you have to know that in our frequency spectrum, in our Fourier series, okay, we have we call as a and a naught, okay, a naught, okay, we have also the bn and cn, okay, the bn and an. All right, so for this one, okay, they are the Fourier coefficient for the an and bn for the Fourier series. Okay, so this one you can refer to the appendices, okay, an, okay, a naught, and also the bn. All right, so the Fourier series symmetrical properties, okay, you can read here. Okay, so the an is merely time average. If it is 0, it is symmetry at the point of time t. Bn is equal to 0, has cosine line even symmetry, and an is equal to 0 when it is odd symmetry. Okay, later on I will show the example. Okay, an and bn is equal to 0 for all even values except for the an. All right, so this one is the example. Okay, if the signal is even symmetry, even meaning that it is like a mirror lah. Okay, even symmetry at y-axis, okay, the period of the t coefficient can be simplified become a naught over 2, while bn is equal to 0. Okay, these properties can be can be read from the appendices. Okay, so don't worry. Okay, so just that you have to know how to read the signal. Okay, for the odd symmetry, so we know that for the odd symmetry, an over 2 is equal to 0. Okay, so the an is equal to 0, while the bn, we have the value for the bn. Okay, the odd symmetry is the odd symmetry lah. Okay, so it is just like the mirror at the y-axis, x-axis. Okay. Alright, so this one is the example. Okay, find the trigonometric Fourier series for the Vt until the fifth harmonic. So this one example, later on you can read by yourself. But the most important part is how actually we can represent the complex exponential. Okay, represent the complex exponential of the Fourier series. Okay, so remember by using the Euler relationship, okay, previously we have learned that cos n omega naught t is equal to exponent negative j n omega naught t plus exponent negative j n omega naught t over 2. Okay, so this one is the sign. Alright, so we know that for the original Fourier series is a naught over 2 and the an cos n omega naught t plus bn sin n omega naught t. But actually the Fourier series general form, okay, this one is the general form, but it depends on the type of the signal. Sometimes it can different type of the signal, and sometimes there is no value for the bn, and sometimes there is no value for the an. All right, so later on I will show you the example where sometimes the value only activated for n is equal to even number. Okay, and then for n is equal to the odd number. Okay, after this I will show you. Okay, so when we refer to this one, we know that this is the original or generic formula for the original Fourier series. The a naught divided by 2 plus the summation of the an and bn. But in our complex Fourier series, we will refer our coefficient with the c naught, okay, as your first coefficient, okay, and this one is when n is equal to 0, And this one is the coefficient of the n started with the n is equal to 1. Okay, so remember when we have the Euler, we have also the negative harmonic. Okay, the negative n. All right, but okay, then the negative n. Okay, the negative value of the n lah because of the negative. Okay, but for this one, for this positive side, okay, because in the Euler relationship, okay, we have the positive side and negative side. That is why we have to do both for the positive n and negative n. Okay, so after this I will show you the example. Okay, okay, now the VT have been simplified. Okay, just now we know that. Okay, just now we know that the VT is equal to the A naught divided by N, right? A naught divided by N is equal to summation of blah, 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 blah. Okay, but now when we want to solve the complex exponential of the Fourier series, okay, the VT just now has been simplified into the version of the C naught, the coefficient of the C naught and also the Cn. Okay, in the appendices, there are several conditions that you need to follow according to the given signal. Okay, all right. So where the Cn is the complex conjugate of the negative Cn. So as I mentioned just now, since in our exponential we have the positive side and negative side, when you want to solve the signal with several number of harmonics, you need to consider the negative number of the n as well. Okay, hence the complex of the Fourier series can be represented in terms of the Cn. Okay, so basically what you need to remember, this one, the purple color one is very important, but this one also is given in your appendices, so you don't worry. Okay, so we have the coefficient n is equal to 0 and the coefficient is when n not equal to 0. Okay, so as I mentioned just now, since we are dealing with the Euler, so you need to consider the negative value for the n. Okay, because you have the conjugate of the n value here, the conjugate of the Cn value for the C and negative n. Okay, all right. Okay, so if you refer here, okay, you can see this one is the Fourier series, the trigonometric form, okay, the coefficient, the properties, and so on. Okay, and then the second one, okay, recall or write the complex Fourier series of the ST. Okay, for example, this one given to you the ST up to the third harmonic. So how we can write the complex Fourier series for the ST given to you the signal, this type of the signal. Okay, so first of all, what you have to do is you have to refer to the Fourier coefficient table for coefficient C naught and also the Cn. Okay, C naught and also the Cn. Then you need to compare directly the given graph with the one in the table. Okay, you need to identify what type of the signal given. And then you have to determine the x naught and the t naught. What is the x naught? X naught is the amplitude. Okay, the amplitude. What is the t naught? T naught is the period. Okay, so from the period you can get the frequency. From the frequency you can get the angular frequency. Alright, so it's very important for you to identify, to calculate, to determine the amplitude and also the period so that you can get the angular frequency. Then what you have to do is you have to calculate the Cn values up to the required number of harmonic. For example, if you want to find the up to 3 harmonic, so n must equal to 3. Okay, so n is equal to 1, 2, and 3. Okay, and then also negative 1, don't forget the conjugate, negative 2, and also negative 3. Alright, so very important. Okay, okay. So now, given to you this type of signal. So what is actually the type of the signal? Let's take a look at the next slide. Okay, so now, if you can see here, just now, given to you is the triangular wave. Okay, so for each waveform, we have different formula for the C note. Okay, you don't have to do the mathematical equation. You don't have to do the integration. You just need to follow, you need to refer to the coefficient table, and then you just need to use the formula given according to the signal, the particular signal in the question. Okay, for example, if you have the triangular wave, so what is your C naught? Okay, this is the formula, right? Okay, what is the C naught? What is the C naught? The coefficient when n is equal to 0 is x naught divided by 2. What is the x naught? X naught is the amplitude. Okay, what about the Cn? When n is not equal to 0. When n is not equal to 0, so you have to use this formula for coefficient of the C. Okay, the Cn value. But there is some remarks here. Cn is equal to 0 for n is even. For n is even. Okay, so there are several types of the waveform you can refer. Okay, for example, if given to you the square wave, square wave, okay, so you can see that your Cn is equal to 0. Okay, your Cn when n is not equal to 0 is here, and Cn is equal to 0 when n is even. Okay, 0, 2, 4, 2, 4, 6, and so on. Okay, so you can refer to the table. Same goes to here. Okay, you can refer to the table for the type of the signal, and then you can get the coefficient of when n is equal to 0 and when n not equal to 0, and but you have to follow the requirement, okay, for several of n. Okay, let's say here. Okay, when you see this question, you have to find the ST. Alright, the ST. So when the ST, we can compare that the signal given is actually the triangular wave. Okay, so now given to you the formula for the C naught and the formula of the Cn. But here, there is the condition where, okay, where Cn is equal to 0 when n is even. The question asks you to find up to the third harmonic. Up to the third harmonic, but n when n is even, C naught is equal to 0. So technically you have to find n1 and n3 only. So don't forget the conjugate, the -1 and also -3. Okay, because technically when you want to solve the Euler, you have the positive side and negative side of the spectrum. So don't forget about the negative side of the spectrum. Okay. Okay, so now from here, okay, we can see that the x naught is your amplitude. Okay, the x naught is 2. All right, and then what about the t naught? The t naught is 20. When the t naught is 20, so meaning that from the period you can calculate the from the period you can calculate the frequency, and then from the frequency you can calculate the angular frequency. Okay, so it's very important. Okay, whenever you want to draw this to sketch the spectrum, okay, please make sure that your x-axis is angular frequency, not the frequency, not f. Okay, must be in angular frequency. So this one is depends lah if you want to draw the amplitude, okay, amplitude frequency, amplitude spectrum. Okay, you have to put here is a. Alright, so if the phase spectrum, this one is the phase lah. Okay. Okay, so now from here we can deduce that, okay, you can find the C naught, right? The C naught, the formula is x naught divided by 2. So automatically we know that when your x naught is 2, so 2 divided by 2, okay, you can get the C naught is equal to 1. Okay, you just need to follow the formula and then you can substitute. Okay, so now what about the Cn when n not equal to 0? Okay, so since this is the triangular waveform, okay, again I mentioned to you, you just need to focus on the odd number, because when n is even, the C naught is equal to 0. So I think there is no purpose for us to calculate. Okay, just waste of time. Alright, so here you just need to follow, but don't forget to write the exponent. Okay, negative exponent j and omega naught t. Okay, it's very important. Okay, because in the table it is not given the exponent j and omega t. You just need to follow the original, the general form of the Fourier series. Okay, that is why you just need to follow the formula of the Cn and then write together is the exponent j and omega t, okay, according to the original signal, because given to you only the Cn, okay, but you need to combine with the exponent j and omega t, omega naught t. Okay, I hope you very clear, okay, up to this point, because after this we need to do the calculation. Okay, let's take a look. Okay, now when we want to do the calculation, okay, just now we know the formula of the C naught, right? X naught divided by 2. Meanwhile, for the Cn, when n is not equal to 0 and when n not is even, so the formula is negative 2x naught over pi n. Where we can get the pi n, we can get the this formula from the the coefficient of Cn from the table. Okay, this one based on the general formula. That is why you just need to follow. Okay, so now we have already calculated the formula, the value of the x naught. All right, so we know that just now our x naught is 2. So you just can substitute. Okay, so same goes to here. We know the formula of the x naught. So you just can substitute here. Remember, I mentioned just now, you need to find, the question asks you to find the equation up to the third harmonic, meaning that until n is equal to 3. And at the same time, you have to ignore the value of n even because the Cn is equal to 0 when n is even for the triangular form, right? So therefore, from here, you just need to find the 1 and 3 for the n is equal to 1 and for n is equal to 3. Okay, same goes to the conjugate value when n is negative 1 and when n is negative 3. So what you have to do, you just need to substitute the value and then you calculate the Cn for 1 and Cn for 3. Okay, so you can get the value. Okay, after that, what you have to do is you have to put the equation. Okay, so remember this one. Okay, this one is the Cn is equal to 0. C naught lah. Alright, the C naught. And then what about this one? This one is when the Cn is equal to C1. Alright, this one is the C1. This one is the conjugate of the C1. Okay, this one is the C2. Alright, and then this one, C3, sorry, C3. This one is the conjugate for the C3. This component, the conjugate. This component is the conjugate. Okay, so what we have to do is, okay, we need to combine with the exponent value just now, because this one you only calculated the value of the Cn, not the exponent. Okay, so you have to combine. Okay, so remember, okay, when your value depends on the value of your n. So for example, this one n value, so you just need to substitute exponent j1, your omega naught is equal to what just now? 100, right? Okay, 100. Okay, 100. Yeah. And then 100 and then you just substitute the t. Okay, same goes to the this one. Okay, this one, the conjugate. The conjugate, we know that, okay, the amplitude is negative 4 divided by exponent and divided by pi squared. Okay, so what about this one? This one you have to substitute n is equal to negative 1. That is why here become the conjugate of the C1. Okay, exponent negative j 100 pi t. Okay, so what about the component, this component? This component is referring to the C3 because we don't have any C2, because C2, when n is even, okay, the Cn is equal to 0. Okay, when n is even, equal to 0. So we just need to consider the C3. Okay, so don't forget to substitute n is equal to 3. 3 times 100, you get the 300. Okay, alright. So since for this conjugate value of the 3, okay, since n is negative 3, that is why you will get the exponent negative j 300 pi t. Okay, so now you can combine. Okay, since you have the similar frequency, angular frequency, you can combine. Okay, 1 minus 4 over pi squared, okay, bracket exponent j 100 pi t plus exponent negative j 100 pi t. Okay, since, remember, our general form must be in positive cosine. Okay, positive cosine. So we know that from here, it is the negative cosine. Negative cosine, right? Negative cosine. Okay, so how from the negative cosine become positive cosine? So we plus with the face of pi. Alright, so remember this one, okay, of pi to become the positive, because if you leave this one is on is negative cosine, negative cosine. So how to convert negative cosine to cosine, positive cosine? So you need to plus with the pi. okay, the phase of 180 degree. Okay, you can refer to the sketch lah. Okay, right, for example here, okay, this one is the cos, this one negative cos. Okay, so from negative cos, we know that to get the positive cos is you can plus with pi, because remember it is okay, it is considered as positively counterclockwise. Okay, positive angle for the counterclockwise. So that is why you plus with the pi, because 180 degree. Okay, and then you will get the positive. Same goes to this one. Okay, you just need to put the phase. Okay, the phase. Okay, in order to convert to the positive cosine. Next, now you already have the signal. Okay, the question asks you to do to sketch to plot the spectrum. All right, in terms of the amplitude and in terms of the phase. All right, so we repeat whatever we have learned in our part 1. Okay, so since this one is referring to the omega naught, okay, omega is equal to 0. Okay, so you don't have any phase here. Okay, so for the amplitude, okay, for the amplitude it is 1. Okay, for the positive side, okay, the amplitude is 4 over pi squared. Okay, same goes to the negative. Okay, so for example here, it is the angular frequency is 100. Okay, so now we need to very important to identify the angular frequency, because for the frequency spectrum, the x-axis is the angular frequency, right? So the angular frequency must be 100 pi, okay, negative 100 pi. That's why 100 pi, negative 100 pi, okay, and then 300 pi, 300 pi, 300 pi, and 300 negative, and 300 negative 5. So now you have to, for example, for the amplitude, okay, for the positive one, okay, the amplitude is 4 over pi squared. Okay, same goes to your negative side, the amplitude. Okay, what about the 300 pi omega naught? Okay, omega. Okay, so for the omega, angular frequency of 300 pi, so we know that both positive and negative share the similar amplitude, right? Positive 4 over 9 pi squared. So you can just draw 4 over 9 pi squared here. Okay, what about the phase signal, phase spectrum? Okay, for the phase spectrum, we know that this one don't have any phasor. Okay, you don't have any angular signal angle. Okay, what about the 100 at omega 100 pi? Okay, the omega 100 pi, your phase, your angle is pi. So you need to draw the pi. Ni rasa macam terbalik ni. I think it is wrong. Okay, because supposedly it is positive pi upwards. Okay, so same goes. Okay, so for the negative 100, it is negative pi. Okay, alright, for the this one 300 pi, supposedly this one is positive upwards, upwards, because of the angle is positive. Okay, and then for this one, okay, this become like this. Negative. Okay, this one positive, this one is positive. Okay, okay, next. Okay, this one is the other example. Okay, given to you the sawtooth signal. Okay, so write the complex Fourier series of the YT. Sketch the double-sided spectrum for this signal until the third harmonic and calculate the average of the power. Okay, this one is the Parseval theorem. Okay, we will learn in our part 3 of the chapter 2. Okay, so now, okay, from here we know that your x naught is equal to 6, and then you from the table you can get the formula for the coefficient of the C naught and also the Cn. All right, so don't forget to include as well the conjugate value, the exponent j and omega naught t. Okay, so from here, okay, you can solve the value, the formula for the C naught and also the value of the Cn. Okay, since there is no remarks here, there is no condition here, and the question asks you to find the spectrum until the third harmonic, so meaning that you have to write this one n is equal to 0, n equal to 1 until n equal to 3. So you have to do every value of the n, every single value of the n until the required harmonic n is equal to 3. Okay. Okay, so now from the table, and if we compare to the signal given, okay, we can deduce that your x naught is equal to 6 and your t naught is equal to 1. Okay, so from your t naught you can get the angular frequency, then your angular frequency is it become 2 pi. Okay, so now, all right, now what you have to do, you have to calculate the c naught. Okay, the c naught, you have to calculate the cn. Okay, the cn, since you have to find the harmonic until to up to third harmonic, so make sure you also find 1 2 3 and -1 -2 and -3. It's very important, because for the Euler, for the exponential, you have the double sided. That is why you have to find the positive sign and negative sign. Okay. Okay, so you have to substitute, okay, the C naught, you have to substitute 6 over 3, 6 over 2 is equal to 3, and then you have to substitute this value, okay, for every single of n. Now, okay, n equal to 1, equal to 2, equal to 3, equal to -1, -2, and -3. Okay, so it's very important for you to substitute for all values of n up to the required number of harmonic. Okay, so now from here, okay, if you can see, I already provide the answer, okay, for the C1, okay, so for the C1, meaning that the C1 x naught, your x naught is equal to 6, okay, so for your J is J, okay, 2 pi, now you are calculating the n is equal to 1, right? So when n is equal to 1, so you have to substitute as well, n is equal to 1. So 3 over pi. So what about the J? Okay, so this is the hint. Okay, when you have the value of J in your calculation, you can convert into the exponential form, which is equal to exponent J pi over 2. Okay, if the J is positive. But if the J is negative, if you combine, you will get negative J, right? Negative J 3 over pi. Okay, you can convert the negative J become exponent negative J pi over 2. Okay, so same goes until the n is equal to -3. Okay, this one you just need to substitute and you just need to convert the value of the J become exponential, whereby when J, positive J is become exponent J pi over 2. Okay, so now you already get the value of the Cn for all value of n until from -1 until 3, right? Okay, so now, okay, you have to combine with this one. Don't forget this exponent, because for this particular box, okay, you are not calculating, you are not consider yet the exponent J and omega t. Okay, you just consider this the Cn here, not here. So you need to combine this answer in the box. You need to combine with the exponent J and omega t. Alright, it's very important because this one is the general formula. Okay, the C naught, Cn exponent negative, Cn exponent G and omega t. So now you can combine, okay, combine according to this one, okay, and then finally you can factorize the equation. Okay, just like the next slide. Okay, so when you factorize, you can get 3. Okay, 3 over pi, this one share similar, what we call it, similar amplitude. Okay, and then since share with the similar angular frequency, okay, angular frequency here, so you can factorize. Okay, so you can factorize lah. You can factorize for both this one. Become 3 over pi exponent J 2 pi t plus pi over 2 plus 3 over this one. Okay, this one. Okay, so when you factorize here, okay, when you factorize here, automatically, okay, you can draw the positive and the negative. Okay, so technically you can combine lah, you can combine the exponent form. Okay, so for example here, for the positive j, okay, for the angular frequency, okay, 2 pi, so we know that your the amplitude is 3 over 4, 3 over pi. Okay, positive and negative angular frequency, positive and negative angular frequency of the 2 pi. Okay, consider the similar amplitude. Okay, same goes to 1 over 5, 1.5 over pi. Okay, for the 4 pi, 4 pi angular frequency, so the amplitude is similar. Okay, for the 6 pi angular frequency, so the amplitude is 1 over pi. Okay, okay, so now what about the phase? What about the angle, the phasor spectrum? Okay, the phase spectrum, for the phase spectrum, again, your angular frequency will be the same. Okay, if you can see here, it is maintained because you want to draw, you want to plot the frequency spectrum. Okay, so you are referring to the angular frequency. Okay, so now just follow 2 pi, 4 pi, 6 pi, okay, negative 2 pi, negative 4 pi, negative 6 pi, because you have the negative side of the j. Okay, this one is the positive side of the j. Okay, so what's next? What's next? You have to identify the angular frequency. For example, the positive j. For the positive j, for the angular 2 pi, okay, so your phase is 5 over 2. So pi over 2. Okay, but for the negative j, negative side, okay, when you expand, you will get negative pi over 2. So negative pi over 2. That is why you draw like this. Okay. Okay, so what about the omega, the angular frequency at 4 pi, 4 pi, 4 pi here. Okay, so let's analyze the positive side. The positive side, when you expand the positive j to pi over 2, so you can see that your angle is positive. So that is why at 4 pi, your angle is positive, pi over 2. Okay, but for the negative side of the j, the conjugate, the next conjugate of the n value, okay, when you expand, you will get negative pi over 2, negative pi over 2. That is why you draw the negative pi. Okay, all right, same goes to this component. Okay, so now what if the question give you the spectrum instead of the signal? Okay, if the question gives you the spectrum, what you have to do is you have to find the expression, the mathematical expression in any form of the graph. You can find the exponential or you can find the trigo. But since okay, this is the double-sided, okay, so it is very important, it is very easy if you can convert your spectrum into the double-sided, okay, into the double-sided. So this one is the C naught, okay, this one is the net C, all right, the Cn, okay, n minus 1 and so on. Okay, so now this one is 3 because the n is not equal to 0. So what about this one? This one is your angular frequency. Okay, so please be very careful. Sometimes the question will give you the frequency here, the f. But when we want to solve this one, you have to convert your f become angular frequency, omega 2 pi f. Okay, so very important. Okay, so this is your amplitude. Okay, they're both positive side and negative side. So 3 over pi. Okay, for the negative side, for the positive side, okay, you know that your angular frequency is 2 pi. So you can write 2 pi. What about the phase? Is there any phase angle? Okay, yes, there is the phase angle, the positive, the pi over 2. So pi over 2. For the negative side, you have the negative pi over 2, meaning that you have to have the positive pi over 2 here, because whenever you want to expand, okay, it will become the negative. That is why when you draw, become negative. Okay, same goes to the other angular frequency lah. Okay, so you can solve the amplitude is 1 over 5 over pi, 1.5 over pi. Okay, for both sides is an amplitude. What about the angle? The angle, you have the pi over 2, pi over 2. Okay, pi over 2. This this one is not 300, and this one is actually the 4 pi. Okay, please make correction. Okay, so until finish, you have to analyze for every angular frequency given in the spectrum. Next. Okay, from the equation, okay, therefore you can have the exponential form. From the exponential form, you can convert into the cosine. Because of what? Because the formula for the cos, okay, so remember cos theta is equal to exponent j theta t, okay, plus exponent negative j theta t over 2. That's why whenever you want to convert to cos, okay, you need to multiply both sides lah. This one divide by 2 and this one must be multiplied by 2. Okay, then you can convert to the cos. Okay, this one is just a mathematical form. So you can do some manipulation so that you can get the value of the cos. You can get the formula for the cos. Okay. Then after that, from the cos, okay, from the trigonometry of the Fourier series, you can draw the single-sided. Okay, so remember, for the trigonometry, you can draw the single-sided, okay, and then if you want to draw the double-sided, you have to convert the trigonometry into the exponential form. Okay, so what if, okay, the signal, given to you the signal in terms of f, okay, so what you have to do is you have to convert your f into omega, into 2 pi f, okay, you need to convert, very important, otherwise your answer is wrong, okay, so omega is 2 pi 200, so it will become 400 pi. Okay, so you need to be very careful with this one. Same goes to this one. Okay, this is the example for the passive question. Okay, so given to you the frequency, so remember whenever you want to draw, please make sure that you convert the frequency become angular frequency, and then when you convert the angular frequency, then you can get the trigonometry, and then from the trigonometry you can get the signal. Okay, so exponential convert to the signal, and then signal you can get the periodic waveform. So I hope that you can accomplish this one so that we can discuss in our class for the next meeting on okay, I hope you do some revision to be discussed in our next class. That's all from me. Thank you.